Hello, this is the reteach for Pythagorean theorem. So first off, remember a squared. Where's this? Oh, I gotta take a screenshot. So let's look at this problem. So we're looking at the problems from the review for this reteach. So we're going to let's take a screenshot here. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared. Now, c is always across from the hypotenuse. So that the biggest square, if you have squares on the legs and the hypotenuse, the biggest one is the area of that is c squared, because if you take c times c, you get c squared, right? And then the legs are a and b. So then the area of region x and y are a squared and b squared. Okay, so you want to add the area of the two smaller squares and get the area of the bigger square to satisfy the Pythagorean theorem. Okay, no. So it has to say it's the same as, and the area for the two smaller ones should be put together. So like this first one, it puts together one of the smaller ones with the bigger one. So you want the bigger one by itself. So the second one here, it says the area cover region Z is the same as those needed to cover both region X and region Y. Okay, and I mean, even if you just use common sense, it would make the most sense for the two smaller ones to add up together to equal the bigger one. It wouldn't make sense for the bigger one and a smaller one to equal one of the smaller ones. Okay, so, but you just need to remember the Pythagorean theorem, and that the area of the squares is the same as squaring the side. Okay. Then for distance, when it asks for distance, it's asking for the hypotenuse. Okay, so when you're looking for, so on this one, it's asking the distance from D to B. Okay, so you already have the sides of the triangle drawn. So if you count the spaces, you should get 12 on this side and 6 on this side. So then you put that in the Pythagorean theorem, a squared plus b squared equals c squared. So you put, since when you're finding distance, you're finding the hypotenuse, that's what you're looking for. You're going to put the 6 in the a squared. You're going to put the 12 in the b squared. And then you just take the square root of both sides to get rid of the square on the c. And then you can put that into decimals just like that. So, okay, so, let's see. So if we go split screen and we go on decimals, guess I didn't get the decimals calculator app, but on your test, you will you can click the calculator. So you just do square root, and then we had 12 squared plus 6 squared. And then you use the A2 button for both of them, even though one of them's B squared. It's just A is a variable. And so like 12 goes in the A and 6 goes in the A kind of thing. You can also do the shift 6 to do exponent and then type a 2. Okay, now on so now the most important thing on these problems is you gotta figure out what you're looking for. Okay, so first figure out what C is. Okay, so if you go across from the right angle, that's C. So C is 13. So H, that's going to go into A or B. And then 5 is going to go in A or B. So we're looking for C squared. Well, we're looking for C. No, we're not looking for C. We're looking for A. We were given C. So, okay, now, actually, H is not A. A is part of H on this problem. So after we get A, we're going to add 2 to get H. So we got A squared plus B squared equals C squared. And you can plug in 6 into, or 5 into, you're plugging in 5 into B and 13 into C. So you have to get rid of that 5 squared, right? So you got to subtract 5 squared from both sides. You get A squared equals 13 squared minus 5 squared, and then you take the square root of both sides. So you get A equals square root 13 squared minus 5 squared. Now you could like square them on each, you could do another step on there and square them and then subtract the numbers and then take the square root, or you can put it in the calculator just like that. Okay, but then on this problem, you would have to add the 2 at the end because it's asking for the total height. Okay. Now, when it says diagonal, okay, diagonal is always the hypotenuse. Okay, so it gives you the diagonal. So you're going to plug that into C. So you got 4 squared plus B squared equals 13 squared. Okay, so and if you didn't like, you could actually, if you don't like using B, you could do A squared. You could also do A squared plus 4 squared equals 13 squared. Okay, so again, you'd have to subtract the 4 squared, and you would get 13 squared minus 4 squared, and take the square root. So if you're looking for a leg, the shortcut really is to do C squared minus B squared. Okay, A equals square root B squared minus A squared. No, it's C squared, sorry. C squared minus A squared. So if they give you the hypotenuse and you're looking for a leg, you do subtraction. Okay, so like on this one too, you're finding the hypotenuse. So you do square root 30. They give you the hypotenuse and you're looking for a leg. 39 squared minus 12 squared. And that will give you x. Okay, so if they give you the hypotenuse and you're looking for a leg, subtract. If they give you 2 legs, you add. Okay, so like this one, you're given 2 legs. Okay, so if you draw across from the right angle, that's your hypotenuse. So you're looking for C. So you would square them, add them, and take the square root. Okay, so you take the square root of both sides, and that would give you the answer. Now, rounding to the nearest tenth, that's 1 decimal place. So like on here, this goes to 1 decimal place. So you round to the nearest to 1 decimal place. Okay. And I think usually you round to the same amount of decimal places that they give you. That's one thing you do in science. You'd have to have the same significant digits as the data you're given. Okay, now on. So this is the shortest distance. Okay, the shortest distance. When it says shortest distance, the shortest distance is a straight line, so that's C. Okay, so distance is C. So you put this into A and this into B, and then take the square root of both sides. So you do 1.7 squared plus 0.9 squared equals C squared. Take the square root of both sides. Okay, now on this one, the last one, okay, so you want to see if it's a right triangle. Now, if it gives you area, you don't have to square it. Like on F, you do 3 squared plus 4 squared, because those are the smallest, and you see if it equals 25 squared. Now, if you're not sure which one's the biggest, you could square them first. So this is 3 squared is 9, 4 squared is 16. So those are the 2 smaller. Wait. 25 is area, so you do not square it. Okay, sorry about that. You do not square the areas. So if it has an area, that's already squared. Okay, so you would do, since 9 and 16 are smaller than 25, you do 9 plus 16 and see if you get 25, which you do, so that checks out. So that one would support the statement. Okay, so if it's asking you if they form a right triangle, you put the numbers in the Pythagorean theorem. If you have an area that's already squared, you don't have to square it. So like on H, you do 9 squared plus 144 equals 21 squared, and see if those equal. Okay. So like on G, I don't think any of those are squared. So that would be like 5 squared plus 12 squared, and see if that equals 13 squared. And then on J, the 100 and the 64 are already squared. So you just do 6 squared and add 64 and see if you get 100. And if they don't equal, then it's not a right triangle, okay? So the same thing if they give you a list of numbers, like if they give you the list like 5, 12, 13, you take the 2 smaller numbers and you square them and add them together and see if you get the bigger number squared. Okay, and like the top one, the first one would be like 3, 4, 5. And this one will be 9, 12, 21. So you take 9 squared and 12 squared, add them together, and see if you get 21 squared. This would be like 6, 8, 10. You do 6 squared plus 8 squared. See if you get 10 squared. Now, if you know your Pythagorean triples, this makes it easier. Like I know 3, 4, 5. So I know J is it would make a right triangle because if you multiply 3 by 2, you get 6. If you multiply 4 by 2, you get 8. You multiply 5 by 2, you get 10. You can take any Pythagorean triple, multiply them by the same number, you get another Pythagorean triple. Same thing with 5, 12, 13. 5, 12, 13 is also a Pythagorean triple, I know. Okay, so the more Pythagorean triples you know, the quicker you can figure out which ones to check and which ones you don't need to check. Okay, so after you watch this video, then you can ask me to take the test. So you can take the test during class, during tea time, or after school during the math and science practice.